Hello and welcome to another video for S2. Today I'm solving May June 2025. This is the variant 65. This came in this year. We've introduced a new variant. Let's start solving. Okay, this is the random variable x has a distribution Poisson. This the sum of three independent values of x is divided by s. Okay. Uh, So the sum of three independent Poisson variables, the lambda will change. So 1.5 times 3, that's 4.5. I just have to calculate, I think, a Poisson distribution. Add it. I can say that I want to calculate the probability of 0, 1, 2, and 3. Okay. So e power minus lambda plus lambda e power minus lambda into lambda power or factorial. Okay. Calculate those quickly. 0.342. Okay, that's the first one. Show that the exact value of less than equals to 2 and less than or equals to 1 is 125. So less than or equals to 2 means 0, 1, and 2. I think I will have to do this without a calculator and show you that some of these are cancelling out. E power minus lambda, lambda e power minus. Okay, so e power minus 4.5 is common to both numerator and denominator. I'm left with 1 plus 4.5 plus 4.5 squared over 2. 1 plus 4.5. So what's 1 plus 4.5 plus 4 point squared? 125 over 8. So 120 divided by 5 over 44. I think in proof for you to work along with. Question number 2 says a random sample of 200 values. Find a 95% confidence interval. So again, 97.5 from my table. These values sort of have changed. So I will have to, this is a concept from S1 where you did coding of mean. Remember that the mean of x minus 2 will be mean of x minus 2 separately. So 60 over 200 mean of x. I want to find the mean of x, so let's that as mean of. So 60 over 200 plus 2, 2.3. That's 2.3. For variance of x minus 2 is the same x. So what is the variance of x minus 2? It's 20 over 200 minus 60 over 200 squared. So variance of x is 0. So So confidence interval then is that at the bottom then x bar is 2.3 minus 1.96 to 0.01 over 100 and the whole thing inside a root because I've calculated the variance 2.3 plus 1. Two point two nine 1. Check my out. So the correct answers. It says state which part of your solution to part A makes use of the central limit theorem. Um, the confidence interval is the part where I use the central limit theorem. The fact that I use a z value of 1.96. Why? Because the original distribution of x was not mentioned as normal. Okay. Okay. Marvela's calculator can generate random numbers between this and that, inclusive correct to three significant figures. She plans to use a calculator to use a sample of members from 851 members in her health club. She numbers the members from 1 to 851. Then she uses her calculator to generate some random numbers. She multiplies each random number by 851 and rounds up to the next whole number to give the number of a member in the sample. This is called a member number. Rola's first random number is 0.401. Find the member number that is produced. 0.401 into 851. So that's 341.251. She rounds up to the next whole number. So she rounds up to member number has to be 342. Okay, then it says find all possible random numbers correct to three decimal places that would produce the following member numbers. Okay, so I know that member numbers come up when I multiply random numbers by 851. Okay, so let's say I wanted the exact member number 680. What would I say that 680 divided by 851? That gives me 0.7990. So 0.799. What I should do is I should also check it again and say that if 799 was multiplied 1.799 was multiplied with 851, it would give me 679.9, and that rounded off would give me 680 at the end. Okay, let's talk about the next one. Let's see, the next one says let's think about another random number. Why? Because I could have landed at 679 point something and I would have gotten the same answer. So 679 divided by 851 gives me 0.798 as the random number. So what I should do is I should also check 0.798 times 851. That is giving me 679.1. That means I've rounded off to 680. That is the number that I'm looking at. If I wanted the member number 850, that's the very last number that I can get. So I have to be careful. Okay, so what's 850 divided by 851? It's giving me approximately, it's giving me 0.99882. Okay, now if I take 0.999 okay, and multiply it with 851. 0.999 times 851 gives me 850.1. Okay, 850.1 according to the rule that this person has mentioned, has mentioned that she would round up. So 850.1 would get rounded off to 851. But I'm not looking at 851. I'm supposed to look at 850. So I should take the random number below it. I should say that the random number would have been 0.998 and not 0.999, because 0.999 gives you a higher rounding off. Okay. Explain briefly how your answers to part B show that Morola's method does not produce uh, a random sample. The fact that 680 came up on two different random numbers. Okay, 680 came up on two different random numbers, and 850 came up on just one different random number. Okay, so that tells me that Marola's method is biased. Why? Because random numbers need to have the same probabilities. Okay, all numbers, all member numbers don't have the same probability. I can see that clearly in the case of these two numbers, 680 and 850. Okay, because 850 is just one shot at it, 0.998, and that's pretty much it. If I go to 0.997, it goes down. So that is the part where it stops being random. Okay, the number of cars and trucks arriving per minute at a fuel station are modeled by independent variables, this and that. Find the probability that at least 4 cars and at least 2 trucks arrive at the fuel station during a randomly chosen 5 minute period per minute. So that's a 5 minute period. So 5 into point 0.8 gives me 4. 5 into point 0.5 gives me 2.5. So cars are at least 4 and trucks are at least 2. So 1 minus probability of 0, 1, 2, and 3 multiplied by 1 minus probability of 0, 1. Okay, let's quickly calculate this. I can use Poisson. I should actually write down something before I. Okay, 2. One minus 0.4335. 0.287. 404. Yep, that is the correct one. Okay, 4A. 4B. Use a suitable approximation to find the probability that a total of fewer than 145 cars and trucks. Okay, so I'm talking about the total now. The total for 1 minute is what? Is 1.3. Two-hour period. Total for 2 hours is 120 into 1.3. 156. I want the probability that fewer than 145. Okay. So I have to first do a continuity correction. Why? Because I'm going to use the normal distribution now. Lambda is large. Lambda is large. X then follows a normal distribution with 156 comma 156. Okay, probability of z less than 0.921 minus 0.921. So phi of minus 0.921, 1 minus phi of point 21 from table to 1.8215. If we have the correct answer, I have 17 as my. Okay, 1785 rounds off to 179 for that matter. Okay, moving on. There's a blank page. Question number 5. It says candidates for certain diploma take two tests. Their mark for the first test and the second test are modeled by this and that. The final mark F for each candidate is found by doubling the mark in the first test and adding the result to the result in the second test. Find the probability that F bar of the final marks of a random sample of 25 candidates is greater than 143. First, I have to find out the distribution of F. The distribution of F is going to have the mean 2 times 38.1 plus 64. What's 2 times 38.1 plus 64? 140.2. Variance. Since I've doubled the marks, it's going to be 2 squared times 3.8 squared plus 6.1 squared. 6.1 squared. $94.97. Okay, 4.97. Okay, then the distribution of F bar is going to have the same mean, but the variance is going to be divided by n. Okay, then for the probability of F bar to be greater than 143, z greater than 143 minus 140 divided by root of 94.97 divided by 5. Z greater than 1.437. 1 minus phi of 1.7. Forcing 0.074. Yep, that is the correct answer. Okay, moving on. Question number 6 says it is claimed that 28% of voters in a certain town vote the Forward Now political party. A researcher suspects that the true figure is less than this. So P is 0.28, and then someone's hypothesizing that it's less than 0.28. Random sample of 30. 4 is the test statistic. So I will calculate the probability of x less than or equals to 4. So 0, 1, 2, 3 and 4, 30C 0, 0 point. Okay, calculate. 0.0495 at the 10% significance level. So 0.495, so 4.95% is less than 10%. So reject H naught. There is evidence that proportion is less than 28%. Okay, then part B state with the reason whether it is possible for a type 1 error was made. Yes, because H naught was rejected. Later, the researchers carry out a similar test using a new random sample. Find the probability of a type 1 error. Okay, so a type 1 error is always found using trial and error. So what I'm going to do is I'm going to start trying. I have already calculated the probability of x less than or equal to 4. I'm going to go to x is less than or equals to 5. So what I will have to do is I'm just going to take the probability of what I calculated, 0.0495, and I'm going to add the probability of 30C 5.72 power 25. Yeah, it's the same sample, so is the size of the sample is the same. So I can just do this. So that gives me 0.116. I have gone beyond the rejection region, outside rejection region. So probability is actually the previous answer, 0.0495. Okay, because when I add the next four term, it takes me outside the rejection region. Question number 7, is that the last one? No, there are two. Question number 7 says a product firm makes a certain type of battery toy. The battery life is denoted by X hours and the population of X is supposed to be 12. The quality control department wished to test whether the population mean is actually less than 12. They tested a random sample of 50 and found that the mean was 11.4. So that's the test statistic. The H naught mu is 12. Mu is less than 12. Okay, so draw the rejection region first at the 5% significance level. The 5% gives you what? It should give me 1.645, so negative 1.645. I calculate the z value of the test statistic, 11.4 minus 12 divided by 2.3 over root of how many? 3. So what is my test statistic then? Minus 1.845. Okay, so reject H naught cos minus 1.85 is less than. Okay. It is given that x bar leads to rejection of the null hypothesis at the alpha percent significance level. Okay. So what I will have to do is I will have to calculate and say that if it 11.4, find the set of possible values of alpha. So 11.4 gave me a statistic of 1.845. So if my alpha is um if I fall within this is my borderline alpha, right? Okay, so I will have to calculate alpha based on this border. So if alpha is less than this border, then my hypothesis will get accepted because the test statistic will get accepted. So I want to calculate the probability of z less than minus 1.845. Okay, minus 1.845, 1 minus 1.85, 1.845, 8, 4, 5, 9675. So 0.0325. So alpha has to be greater than 3.25% for my null hypothesis to get uh, rejected. If it's anything less than 3.25%, it's going to get accepted. Okay, moving on to question number 8. Question number 8 says the diagram shows the graph of the probability density function between x0 and xa, the graph of the straight line O with gradient k. Okay, so the equation of this line should be y equals to kx plus 0, where k and a are positive constants, elsewhere f of x is 0. It's given that the median is root 2. So what I can conclude is that this area should be 0.5. And the value of k. Okay, can I find the y coordinate in this then? It's going to be k root 2. So half base to height. So 2k over 2 equals to 0.5. K is therefore 0.5. Okay. Find the value of the expected value of x. The expected value of x can be found by x f of x and integrating from 0 to a. Okay, it has to be not in terms of a, I think. I will be able to find a in a bit. Let's do that too because I can now see that I can integrate from 0 to a the function 0.5x and say that it equals to 1. I'm going to first calculate a so that it simplifies my calculations. So that's a squared over 4 minus 0 squared over 4. Okay, I've just done my calculations quickly. A squared is 4, a is therefore 2. Okay, so 0 to 2. Of what? X f of x. So x 0.5x. 0.5x squared integrated 0.5x cubed over 3. 0 to 2. 0.5 to cubed over 3. 0.50 cubed. I hope I'm getting the correct answer. Gives half, okay. A is 2, that's also 0.5 into 8. 4 over 3. 4 over 3. Okay, that's the end of the exam. Oh, I didn't notice that. Thank you for watching. I'll be back with another past paper in the next.